Okay, so to continue with this idea, we're going to go back to that cat person, dog person example that we did in section 7.2. It says, suppose the population, though now, is 1,000 people, and the proportion of cat people is still 25%. We're going to take a random sample of 100 people. We want to answer the question, what is the approximate probability that the proportion or percent in our sample will come back bigger than 29%. So we're saying we know that the true value, that whole value, the cup, is 25%. Then what's the probability that when we take a sample that we'll get something bigger than 29? Like that we'll miss it by more than 4 percentage points in the high direction. Well, the first thing we need to do are check those conditions for the CLT. So let's check them. Number 1, do we see the keyword random here? Random sample. Check. Number 2, we have to check that taking a sample of 100 people, was this big enough? Okay, so we have to check, is NP greater than or equal to 10? And is N 1 minus P greater than or equal to 10? Okay, the N, the little n is that sample size, so in both cases it's 100. Checking greater than or equal to 10. Well, the P is the percent, is that proportion, so that's the 25%. And this is 1 minus 25% or 0.75%. So are those both bigger than 10? 25, yes. 75, yes. And then number 3 we have to check, is the whole population of this world bigger than 10 times the sample? In this case, the whole population is 1,000. Is that greater than or equal to 10 times 100? Well, we just barely made it this time. The or equal to is there, so this works. It's just barely a big enough population for this to work. When those conditions are met, we can use the formula we learned last section for calculating standard error, the square root of P1 minus P over N. We can calculate that value out. So we've got 0.25 times 0.75 for 100. This comes out as 0.0433 approximately. Okay, so far all we've done is check the conditions and do a little bit of side work finding the standard error. Now what we want to do is actually answer the question. The question says, what is the approximate probability that the percent in our sample will come back bigger than 29%? So we want to use StatCrunch now. Now we finally get to go to StatCrunch. We're looking for what's the probability of getting a value greater than or equal to 0.29. And we're going to employ that what we know from the central limit theorem. So kind of going back to the beginning here. The central limit theorem said if we meet all these conditions, we should have an approximately normal distribution with mean P and then the standard error in the back there for standard deviation. So what am I going to put here? Well, the mean is going to be P, so the P value here was that 25%. It's what we expect to happen. But with plus or minus this much, that standard error goes here. This right here is the part that everyone always forgets about. The what do I put here? Well, you have to calculate that out. The StatCrunch doesn't just automatically tell you that necessarily. You have to know that formula, get it calculated out, type it in. Now we can go to StatCrunch. So now I'm going to basically put all of this information right here into StatCrunch to find the final answer. So I've got StatCrunch loaded in another window here. So we're going to go under our Stat menu and pull up our normal calculator. I know this might look weird, and it's because I'm doing it on my tablet instead of my desktop this time. So the menu looks different, but it's all still there. All the same things are here. Okay, so I bring up that normal calculator. Because we meet the CLT, we can say this is approximately normal. So I can calculate things with the normal calculator. I'm going to put in the mean of 0.25 the standard deviation of 0.0433, is that right? Yeah, 33. And I am trying to find the probability of getting greater than or equal to 0.29 out of this. And I can hit compute. And right down here, it shows me 0.1777. So I'm going to round that off to about 0.18. That's what I'm going to record. I'm going to go back to here. So what I got out of StatCrunch was about a 0.18 or an 18% probability of getting back 29% cat people or more from a sample. So if there really are 25% cat people in this world, and I take a random sample of 100 people, there's only an 18% probability that that random sample is going to have more than 29% cat people in it. That is the question that was laid out, and that's the answer we can now get back. Okay, let's do one more example using this CLT then. This one says, Samuel Morse, the inventor of Morse code, claimed that the letter E is used the most frequently in the English language, and the proportion of E's was 12%. The most frequently used letters needed to be easy to type, so in Morse code, E is simply the dot. It's the easiest one to type. To check this proportion, a simple random sample with replacement was taken from a large modern-day book. The sample consisted of 876 letters, and 118 of them came back E's. First question, what is p hat? So remember, p hat is that sample proportion or sample percent. So what was the percent that E's that came back in our sample? 118 of them were E's out of 876. We divide that out, it is about 0.1347 or about 13.47%. So in our random sample, we got 13.47%. He claimed it was 12%. Again, samples are expected to miss the true value sometimes. We hope by not a lot. So we're kind of thinking right now, was this just a random miss? Like, were we close but off by just a little bit because of the random sampling? Or do we actually not think it was 12 anymore? So that's kind of the questions that should be rolling through your head right now. Okay, it says, assume that the true proportion of E's really is 12%. We want to find the probability that if we were to do this again, if we were to take another random sample of 876 letters, what's the probability that we would get something greater than or equal to this? What's the probability we would be off by this much or more if we were to do this a second time? Okay, let's check those conditions to see if we can use the CLT. Do we have a random sample? Yes. Was our sample big enough? Okay, our sample was the 876, and the probability of an E is 12, so we're checking to see is that bigger than 10, and we're also checking to see is the probability of opposite of that bigger than 10. Well, this one comes out as 105, so yes. And this one comes out much bigger than that, like 778. So again, yes. Be sure to pause me and do those calculations for yourself. Make sure you and your calculator are working together well. And then the last one is the population at least 10 times the sample size? So the population, well, here, let's think about the sample size first. The sample size is 876, so I know what this side is. The whole population here, they were picking these numbers from a large modern day book. So do we think that letters in a large book. Letters in a large modern day book. Are there more than 8,760 individual letters in some large novel? I would venture to say yes, there are. And that's what happens a lot of times on those too, is we have to kind of sort of wave our hands. Unless there's some real particular reason for me to think no, probably these are going to be okay. Okay, when we hit all three of those, we can then calculate up that standard error. Okay, so P is our 12%. 1 minus that is 88 over the sample of 876. And when I calculate that out, I get 0.010979. I'm pulling that one a little farther out because it's such a small number. Okay, so the question was, what's the probability that we would get something greater than or equal to this value we got the first time? And because of what we got with our meeting our criteria here, we're going to say in a approximately normal distribution with mean equal to what we expect and standard deviation equal to what we just calculated. Okay, so I'm going to flip back over to StatCrunch, type those values in, and finish up that question. So I just need to change my numbers here. This time I expect 12%, give or take a very much smaller give or take amount here, 979, and I want to find the probability of getting greater than or equal to the first value that was found. So it looks like it's like 0.09, so it's really a 9% chance. That's what we've got going on here. So it's 9%. 9% chance of getting the 0.1347 or more in another sample.